Hi, everybody, and welcome to this recorded interview, this chat with geologist Don Swanson from the USGS. And we've already done one of these, and I enjoyed it so much that I asked Don if he'd be willing to come back and we just pick another topic, another theme for his work in the South Cascades of Washington State. Don, what's the weather report this morning from the back patio in Hilo, Hawaii?
Well, the weather is great and the volcano is quiet, so things are looking up.
I love it. I love it.
Yeah.
Well, let's get right into it, just like we did last time. You are aware, Don, that I'm ramping up for a series of new programs on the South Cascades, and I'm involved in two projects now between Goat Rocks and Hannah Shamloo and her team, and Spirit Lake Pluton with Mike Eddy and his team. And so we're just kind of dealing with those two areas, maybe the Never Never Land between St. Helens and Goat Rocks. Do you have some themes that we did not talk about last time that might be something that you want to share, possibly involving the Quaternary? Is that one of the things you might want to deal with today?
Yeah, in that Never Never Land, there are quaternary vents. Not so many, I think probably 20, but they're mainly concentrated in two or three areas. But I'd like to discuss them a little bit as to their implications. And then I'd like to describe a 13 million year old radial dike and sill swarm around a mineralized pluton that I think reflects a pretty big volcano that has been eroded down to its roots over time. So
Love it. Love it. Which one do you want to do first?
let's do the quaternary first.
Good.
We'll
Good.
work backwards in time. Yeah.
You know, I have a little surprise for you. I've been busy with interlibrary loan at our university, so of course I now am the proud owner temporarily of your PhD from Johns Hopkins back in
Oh,
1964. I got a lot of reading to do here, Don. Are we going back that far with your discovery of some of these quaternary vents, your PhD in the early 60s?
no, thank God we're not. No, we're only going back to my work from about 1987 or 88 until the early 1990s, while I
Okay.
was still at the CVO in Vancouver. And
Yeah.
um, so what the the closest? Well, first of all, there's, as you described, this Never Never Land between Mount St. Helens, Mount Adams, and the Goat Rocks, in which there's very little happening in the Quaternary in terms of volcanic activity, but there is something. And the nearest cluster of Quaternary vents, basalt and basaltic andesite, to Mount St. Helens is about 20 miles to the northeast. So it's beyond the scope of any influence of St. Helens, I think.
Okay.
And these there are a couple of vents, or one vent that I found and one flow remnant at a place called the basalt of Badger Ridge and the Loaf. The basalt of Badger Ridge has been dated as around 650,000 years. Now, whether that's a
Hmm.
good date or not, I'm not sure, but
Okay.
all of the flows are magnetically normal. So, and this raises a point. I always had a portable fluxgate magnetometer with me when I was doing this work. And so every time that I found a quaternary, what I thought was a quaternary rock, I would determine its polarity, negative or positive.
Sure.
Anyway, these flows from these two sources apparently flow down into uh, previously glaciated valleys. And then uh, later Hayden Creek glaciation has removed the portions that were in the valley, so the flows now form ridge crests.
Oh, wow.
So you've kind of inverted the topography in a
Yeah.
sense, and so they're really quite nice. They're just run of the mill chemically, and nothing too exciting about them. But now we go farther northeast, another 20, 30 miles to a place that's called Blue Lake. How many Blue Lakes are there in the world, I wonder? But this is my Blue Lake.
Okay.
and the adjacent area of Juniper Creek. And there are some really interesting deposits and structures. The around Blue Lake, there was a cone that was developed. There was something like 800 meters high, maybe probably more than that, and 2.5, 3 kilometers wide. This formed during the presence of ice. I think Hayden Creek ice was occupying the Sispus River and going up high up onto the valley wall. And the lower part of the Blue Lake volcano was erupted in ice because it's hyaloclastite. It records the interaction, explosive interaction in places of water and magma high above the valley floor.
Huh.
And then you reach a level at which this hyaloclastic uh, uh, basal level stops, and you get into a more normal lava flow with only a minor amount of evidence of interaction with water. And then above that, there's a cone of tephra that shows no interaction with water. So I think this is really a really good example. Blue Lake volcano is a very good example of a volcano that began erupting through the Hayden Creek Glacier,
Wow.
topped out of the glacier, and then built a cone above the top of the glacier.
Well, this
And
speaks.
yeah,
Go ahead.
go ahead.
Well,
Go
this
ahead.
speaks to your experience as a mapper. I assume this is part of those quads that you're mapping, and you're mostly working with tertiary units. Is this Ohanapikosh? Is this something else? What is
Yeah,
the context for you kind of stumbling onto these very young features?
stumbling on is a good way to put it. But you know, when you're working with the older rocks that are uh, lightly metamorphosed, and then you suddenly find
Yeah.
fresh rocks with olivine visible when hand lens, fresh and so forth. These rocks really stand out. And
Huh.
so the interesting thing about Blue Lake volcano and the adjacent um, basaltic vents near Juniper Creek uh,
Okay.
is that uh, 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 Juniper Creek, incidentally, was also subglacial, and then it built a cone above the top of the glacier. They they are relatively rich in potassium, and so therefore they should be easy to date with modern dating techniques that weren't available when I was doing the work. And the importance of that, not only just to date the flows itself, but you could then date the uh, presence of the Hayden Creek Glacier at a particular level. That level being the top of the subglacial part of the volcano.
Huh.
When I was working, the Hayden Creek was had a wide range of ages for it, but 140,000 seemed to be the preferred date. I have no idea if that's still the case or not. I haven't kept tabs on it, but in
Sure.
any case, it would be easy to now to get some good ages on the lava flows and to use that to constrain the Hayden Creek. So I think there's really a nice opportunity there for interaction between geomorphology, glaciation, and volcanology.
Yes. Okay. Two main questions from me based on that. One, were you doing this in a vacuum, or were there other geologists nearby also documenting these quite young vents in between present cones? And two, why are those vents existing where they are? Is there what at the time or versus now? What's the general way to explain why those vents are located apparently all over the place?
Well, your first question is that no one else was working in the area. Paul Hammond had done some reconnaissance work, but had not keyed on these particular events.
Hmm.
And but then I got some advice from Barry Goldstein, who was teaching at UPS at the time, and a geomorphologist, but I was the only one really looking at the deposit. Blue Lake volcano had only been recognized 10 years earlier or less
Wow.
by a couple of Forest Service geologists, and I was the first one to recognize the Juniper Creek stuff. It's an interesting story there. Of course, I didn't have INSAR imagery to work with in the late
Right.
80s,
Right.
but the 7.5 minute quadrangles were really quite good. And there was up on the slope, on the ridge slope above Juniper Creek, there was an interesting little saddle. And I wondered what in the world could be causing that saddle. So when I went to it, and that was a saddle between the general slope of the ridge and the tertiary rocks, and a little cone that had grown up, and the Juniper Creek cone. So it was an interesting marriage of sort of interest in what was happening and the availability of a good quadrangle map that allowed me to find that stuff. Now, your more important question as to why the vents are there, I have no idea. They incidentally, let me explain further about before I try to answer that question, or before I
Yeah.
tell you why I can't answer the question. These rocks at Juniper Creek and Blue Lake Volcano are part of a southwest trending zone of high potassium basalt and basaltic andesite that extends down to and south of the ridge crest between the Sismus drainage and the Lewis River drainage. Southwest is an unusual direction in this area. In this Never Never Land, everything is striking northwest. So
Yeah.
why would anything be going southwest? And this is a big puzzle, but it's part of my lack of understanding as to why the vents are there. And somebody can go back and take a look at and check and revise my mapping and rethink this and perhaps come up with a model for why the vents are there. But it's really quite amazing that they're sitting out there really in the middle of nowhere. I mean, they're far away from all of the big volcanic centers. They're quite rich in potassium, as I said, up to 2.2% K2O, and most of them are about 1.2% K2O. So it's quite striking. And but there they are. They're the rocks.
Well, yeah, let's keep going with this before we switch to your other topic, please, because I am getting more and more interested in this. Are most of these vents mafic? And what else would I know in southern Washington that possibly could be lumped into these vents you're talking about? Like I think of Spiral Butte or Tum Tum and some of the others closer to White Pass, or even that Hogback vent in the Goat Rocks. Is that in the same? How similar are those places
Well,
to this
I,
concept?
I would say these are more similar to first of all that they're basalt. They're all basalt, and there's no andesite or dacite in there.
Okay.
And they're probably more akin to what was present in the Indian Heaven
Oh,
area that farther south east that Paul Hammond had done some work on. Though this is certainly far away from Indian Heaven, but it's that kind of thing. At Indian Heaven, Paul found some subglacial
yeah,
basaltic vents, just like at Blue Lake
yeah.
and Juniper Creek. So, but I wouldn't want to necessarily relate them to anything else. I think they're
Hmm.
just sitting out there that deserves, and they deserve their own explanation.
Well, yeah, final thought, like maybe somebody's watching this and going, how could you miss these most young features on a landscape? And maybe the viewer is imagining you sitting on some ridgetop, seeing all this stuff strewn out below you in the valley below. But it's forested, Don, and you don't have all the imagery we have today. And so I'm guessing that you were bushwhacking to find little pieces of the Blue Lake volcano here and there and trying to put these things together on your map. Is that more accurate? You didn't have a broad vista of all these features.
No, no, it was bushwhacking, and
Yeah,
road cuts helped a lot to get me started.
right.
And they kind of confirmed what I'd been seeing along the creeks, and spurred me into looking for more. But no, it was just the classic mapping that I was doing, uh, just being persistent, and things just kind of fell out that way. And
Yeah,
that's persistence in field geology is one of the most important requisites, I think. You just sort of never give up if
excellent.
you absolutely have to. So
Yes, yes. Well, I mean, your work speaks for itself, and that's just one chapter of your very storied career with the USGS, which we will continue to hopefully visit with you about. Maybe it's time to switch to the other topic that you wanted to include here today. So we're suddenly a little bit older, maybe quite a bit older than our Quaternary vents, but we're still in that area between Goat Rocks and Mount St. Helens.
that's right. We're in an area that's uh, south of Sispus Center and Tower Rock, 12, 15 kilometers or so. And I
Yep.
started seeing uh, thick sills and vertical dikes that contained hornblende, fresh hornblende crystals. And hornblende, excuse me, there's a insect here flying around.
Oh, you're not on a set right now? That's not a green
Yeah,
screen behind you.
no.
You're actually in Hawaii. That's good to know. Okay.
Fresh hornblende is really rare in this area, and there were these hornblende needles that you could easily see with a hand lens in the dikes and the sills.
Mhm.
And so, and not only that, but the rocks were much fresher than the older tertiary rocks that they were cutting.
Yeah.
And the dikes were vertical and cutting, dipping tertiary rocks, dipping 20, 30 degrees or so. So that really raised my interest. And so then I paid particular attention to the dikes and sills in my mapping. And every time that I found one, I would note it on the map. And it turns out that the dikes form a radial swarm that's probably 12, 15 kilometers in diameter, focusing in on a mineralized pluton, the Camp Creek pluton.
Camp Creek.
Camp Creek pluton, which is up in the McCoy Creek drainage, it turns out. Well,
Okay.
the dikes are found in all of the quadrants around the Camp Creek mineralized zone.
Okay.
And then they're associated with these sills that I have been looking at. And some of the sills are very thick, a couple hundred meters or so. And the sills are also hornblende bearing.
Huh.
You can trace them uh, both to the southeast from Camp Creek and particularly to the northwest from Camp Creek. And you start mapping them, and it turns out that they go all the way up to the Sispus River west of Sispus Center. And there's a very prominent uh, spire there called Tower Rock,
Yeah.
aptly named.
Right.
Tower Rock is the thick end of one of these hornblende bearing sills, hornblende
Oh, it.
microdiorite and diorite sills. And you can
Oh.
walk that back all the way back to Camp Creek. So the picture is that there is a mineralized uh, pluton around which there is a radial dike storm, and many of the dikes fed sills, which preferentially intruded along the strike of the host rock, which was northwest southeast. So that's why most of the sills are found northwest and southeast of Camp Creek, whereas most of the dikes, not all, but most of them occur southwest and northeast of Camp Creek. As the as magmatic pressure was building underground, it would fracture the rock, and magma would be injected into these fissures if the fractures happen to be along the strike of the host rock, of the
Uh-huh.
tertiary rocks.
Yeah.
Then magma would more easily flow into in that zone, forming sills that contained a lot larger volume than in the dikes themselves. So here you have a wonderful example of the subterranean roots of probably a pretty large volcano, maybe on the order of one of the existing Cascade volcanoes today. But all that you see are its roots. And
Well, that's
interestingly enough, the hornblende in the dikes and sills, as you approach the mineralized pluton, the hornblende becomes altered as well. So the alteration that was affecting the the pluton, or the magma body, was radiating outward and affecting the dikes and sills that were just slightly older. We've obtained several ages for the dikes and sills. Potassium argon age of around 13 million years. Fission track ages that I obtained with Joe Vance of about the same. So, and this is important because a paleomagneticist named John Hagstrom drilled the dikes and sills and got the orientations, and they're consistent throughout all these units. Incidentally, showing clockwise rotation as is
huh.
true throughout the Northwest.
Yeah.
Um, and whereas 29 million year old bedrock just to the northeast of there that has been folded has was also drilled by John, and that he applied a fold test to the magnetic data. And if you unfold the tertiary rocks, the pole positions come out to be really nice. So that indicates that the folding took place, or that the folding took place after the am I getting this right? The dike, wall rock, and the magnetic polarities are consistent with the folding taking place uh, uh, together with the magnetics, and then the magnetics and the host rock folded together. Yes, that's what I was trying to say.
Well, I've
And
got it.
in
Yeah.
contrast,
Go ahead.
the hornblende bearing dikes and sills fail a fold test. If you try to unfold them to make them consistent with the dip of the host rock, then their directions go astray. So this allows us to say when the folding in this part of the Cascades took place, or at least when it ended. It ended sometime between 19 million years and 13 million years along the northwest trending fold axis. So that's pretty striking, I think, and it's a really good example of how PMAG can be used to help to unravel the tectonic history of this part of the Cascades.
Well, that's a surprising turn towards the end there. Like I didn't know we were heading there, but that excites me to get ages, bracketing ages of folding. I don't know if the folding is really tied to uplift of the high cascades necessarily in developing a rain shadow. This is maybe something more akin to folding in the Yakima fold and thrust belt, or do you
Yeah, I don't,
what?
this is a big question that I've asked myself over the years as to whether or not there's been continued uplift
Yeah,
independent of the folding, or if the uplift ended when the folding ended, say before 13 to 14 million years. But so this remains a problem that people
yeah,
can look at. The rain shadow existed during early Ellensburg time, vantage time already, so it was there by 15 million years or so. But the CRB has been warped up since 15
yeah.
million years, so clearly there was some uplift that occurred after it was in place as well. So just putting all these things together is remains to be done by some smart people in the future.
Well, there's a lot there, and that's part of what I'm trying to do is take some of this fine work from decades ago and make sure that people know how to find it if they want to do a little bit more work. Like in here, for instance, you're talking about radial dikes tied to the Tieton volcano. How is
Yeah.
that radial dike story different than the radial dike story you've been talking about today? Were there hornblends in the Tieton volcano as well?
No, a Titan there was not. Those were pyroxene andesites, but there is a
Eh,
striking difference on that side of the Cascades in the Titan Basin. There's uh, the you only see low down in the volcano. In fact, you don't see the guts of the volcano. You don't see the solidified magma reservoir. Whereas over at the what I call the Kid Creek
yeah,
volcano, the Kid Creek area, there
yeah.
you see much deeper. You see down to the Camp Creek intrusion. And so for some reason, we don't know, I don't know the answer to the erosion bit much deeper into the Cascades west of the crest than to the east. And I
Huh.
don't know why that is. One possibility that's come to mind is that in the Titan area, uh, the the volcano was covered soon after it formed by Grand Ronde basalt,
Yeah,
and the basalt may have been much more difficult to erode
right.
than the uh, uh, than the rocks in the Kid Creek area where the basalt apparently was not present. So erosion could have progressed there much more rapidly than in the Titan Basin. But I don't know. That's just one idle speculation.
This is so perfect for what I'm trying to do, Don, and I'm so grateful for your time with these. I'm kind of searching for narratives that just kind of bubble up naturally. And so this Kid Creek versus Tieton volcano is a perfect back and forth study. We've got a younger Kid Creek volcano that's more deeply dissected than the Tieton volcano.
Right.
Uh, and then we're not bordering on any kind of explosive silicic caldera forming things, which we've been doing in the last couple of programs. I don't think like the chemistry is wrong, and there's no hint of that. But maybe we can finish today with just a brief comment. You said something in the last interview. I don't mean to make trouble now, but you commented on Paul Hammond being such a gentleman, and he was and is and continues to be a wonderful colleague. But you did mention that you often didn't agree with Paul with some of the interpretations, possibly. Is it with some of these volcanic centers? Was he more what different? Can you give us a couple of examples about how you maybe agreed politely or disagreed politely with Paul Hammond over the years?
Well, yeah, Paul liked to extend the Hanapakash, Stevens Ridge stratigraphy south from Mount Rainier, and so and as I explained last time, I was loath to
Right.
do that, and so
Right.
he may end up, being correct from the point of view of the rocks being coeval throughout that area, but I think they had different sources and
Mm.
but and there's some other minor problems that I can't remember now. But
Sure.
Paul, see, I spent in the area that I'm at, I spent 7 or 8 years mapping. Paul did that in maybe a summer or so. So how I can, you know, you can't criticize someone who gets so many things right so quickly.
Yes, yes. Very perfectly said. Well, Don, it's a thrill yet again to do this. Please hold the line. I'm going to stop the recording and we can talk for just a couple more minutes. But I
Okay,
appreciate your time today. I hope we can continue doing this down the road. But great to spend time with you today. Thank you for your time, Don.
thank you.
Okay, we'll see you next time.
So long.